All right, here I've got a video where we're going to talk about rational exponents. And what a rational number is just basically any number that can be written as a fraction in layman's terms. So we're basically talking about fractional exponents. This includes some decimals and things like that. But for the most part, when you have a problem or an assignment that's talking about rational exponents, that just means exponents that are fractions. So we're going to cover two main ideas. The first idea is this: what does it mean if an exponent is a 1/2? We could extend that to, what does it mean if it's a 1/3 or a 1/4? What if it's 1 over anything? What does that mean? And once we understand that, we'll be able to explore this second idea, which is what does it mean if the exponent are some other fraction, such as 8 to the 2/3. Some of the background knowledge that we need is you need to know exponent properties before we get into this. If you don't know your basic exponent properties, you're not really going to understand what we're doing in this video. So either Google search exponent properties or YouTube search exponent properties. And we just also need to understand some basic stuff. Obviously what it means to square a number, what it means to cube a number, what it means to square root a number, and what it means to cube root a number. Those are things that we need to understand before we go any farther. So if not, just YouTube search or Google these things, and you'll get it and you'll be ready to move on. So some notes or some vocab before we get started. We need to know that radicand means the number under the radical. The radical is the actual symbol. Now some people will kind of refer to this whole thing as a radical, but for the most part when you hear people say radical, they mean the actual symbol there. And then the index is that number right there. So yeah. So here's our first learning target, our first little objective. And the first thing we know is, what does it mean if my exponent is a 1/2? So here we have 4 raised to the 1/2 power. What that actually means is that means the square root of 4. Okay, you could put a little index of 2 there. That's what it means. What number times itself 2 times gives us a 4. But for the most part, when it's a square root, people don't put that index there. But the 4 to the 1/2 is the same thing as the square root of 4, which is the same thing as 2 if you were to simplify it. And so that's the basic idea. We could extend this and say 8 to the 1/3, or some number to the 1/3 power, is going to be 8, not square rooted, but cube rooted, which in this case would also be 2. And so then we could, extend it even further. We could say, something to the 1/4 is the 4th root. Some number to the 1/5 is the 5th root. And we can keep going. So there's your basic relationship right there, though. Now, if you don't trust me, let's prove it. Okay, so we're going to come down here to the bottom. We're going to prove why that's the case. So just to explore it, I'm going to start with this relationship. The square root of a is the same thing as a to some exponent. And our goal here is going to be to prove that exponent k is 1/2, to show that square rooting a number is the same as raising it to the 1/2 power. That's going to be our goal here. So I'm going to start with taking both sides of the equation, and I'm going to square each side, because I can do anything to one side of the equation as long as I also do it to the other. Okay? Squaring and square rooting a number, those are inverse operations. Those undo each other and just leave us with an a, I'll make that a little bit bigger, an a on the left side of the equation, and then we have a to the k squared on the right side of the equation. Little side tangent over here, if you don't believe me, if I have the square root of some number and I square it, well, the square root of 4 is 2, and then 2 squared gives us a 4. Basically, those are inverse operations. They undo each other. That's why the square root of a squared just gives us a. So this was a little aside work in case you didn't believe me on that step. And so let's come back to our main proof over here. Now, any number, if I don't have an exponent right here, that exponent is really just an invisible 1. So we have a to the first power equals a to the k power squared. Well, here's where our exponent properties come into play, because if you take something, a power, and raise it to another power, what you're basically doing is multiplying those exponents. So we now have a to the first equals a to the k times 2. So once again, to get from here to here, we just used our exponent properties, okay? Now, we have some number raised to some power is equal to that same number raised to a power. Therefore, for these to be equal, we know that the exponents must be the same. If 1 is equal to k times 2, I'm just going to divide by 2 on each side of the equation, and we end up with what we want, which is k equals 1/2. So if we go back to the start, that's what we were trying to prove. We're trying to prove that some number, square rooted, is the same thing as k to the 1/2 power. Okay? So all this down here, if that bothered you, if that threw you off, if you watched that and it made you angry, that's okay. Just come back up here to the top and take my word for it. Anything raised to the 1/2 power is square rooted. Anything raised to the 1/3 power is cube rooted. Okay? And that's kind of our first learning target. Now, just to get some practice at it, let's go to the next slide. If we're trying to simplify 81 to the 1/2, we just learned that means that it's 81 with an index of 2. And when the index is 2, you don't really mention that. We're basically just taking the square root of 81. The square root of 81 is basically a 9. Or not basically a 9, it's exactly a 9. And let's apply it to this one down here. Now we've got 125. Since it's raised to the 1/3 power, that means we have an index of 3. And just to refresh your memory, to cube root a number means that we have some number times itself 3 times that gives us that 125. So you could either punch this into your calculator or use some guess and check and figure out the answer here is 5, because 5 times 5 is 25, and then that times 5 gives us the 125 that we're looking for. So here's a couple of practice problems applying what we already know. Let's move on to our second goal. Our second goal, or our second learning target or objective, whatever you want to call it, 2, is what if the fraction's some other number? What if it's 8 to the 2/3 power? If we have an exponent that's some other fraction. Well, that's going to be, in this case, it's going to be 8 raised to the power of whatever this numerator is, square rooted, and the index is whatever that denominator is. Okay? If I wanted to simplify this, I could do 8 squared, which is 64 cube rooted, and then some number times itself 3 times gives us 64. In this case, that number is a 4. But the basic relationship that we need to understand is getting from here to here. And so once again, if you don't believe me, let's come down here and let's prove it. So if you don't like proofs and you trust me, you can just fast forward to the next part of this video, but I'm going to show, for the people that are curious, why this is the case, why we can do this relationship up here. So if I start with, and our proof's going to take a little bit different form this time. We'll just start with x to the m over n, x raised to some power, and I want to rewrite this first. And I'm going to rewrite it as this. Okay, because m over n is the same thing as m times 1 over n, so I just have this big exponent. I just took my exponent and I rewrote it from that step to that step. And now what I'm going to do is this. We only multiply exponents when we raise a power to a power. So from here to here, we're going to apply our exponent properties. And then notice what we have. Notice our exponent out here. It's a number raised to the 1 over n. Okay, so we have, just consider this entire thing our base right here, and it's all raised to the 1 over n. That means, according to what we've already learned with that first objective, that it can be rewritten as this. Okay, remember how when we took like 4 to the 1, I'll say 1, if we took some number, let me go a different number. Let's say if we took 125 to the 1/3, that became 125 cube rooted. This is what we just learned, right? Well, now I'm applying that. I'm saying, okay, I'm going to take all this stuff in here, and that whole thing is having that exponent apply to it. And so that's how we get from that exponent to that radical with that index. So if I get rid of some of my markings here, we end up with this relationship. And so what we've done is we've gone mathematically from this guy up here to this guy down here, and that's proving the relationship that I showed you up top. Now, it's not the cleanest proof, but it's algebraically correct. If we go to our next slide, on this next slide is where I actually show it a little bit cleaner. So this is that property that I would write down if I were you. know that if you're given a base with a fractional exponent, it can be rewritten as either one of these, and basically these two are interchangeable. I think I proved it this way. We could easily prove it this way using the same strategy, and just kind of looking at your exponent a little bit differently, but I'm not going to go there in this video. But just know that all three of these representations are the same. I could look at it like that, or like that. So you might want to pause the video and write that down. But we're going to move on to just a couple little practice problems where we're going to apply this for practice. So I'm going to start with 49. And then here, I don't know why I just wrote 42. We're going to apply that exponent. So we learned that the numerator of that fraction is going to stay as the exponent, and the denominator of that fraction is our index. Now, I could do 49 to the third power and then square root it, but we learned on the last slide that we got a couple things that are interchangeable. I could rewrite it like this. Keep doing that. Square rooted and then raised to the third power, because we don't really need that 2 there, okay? And so, remember, this is on that very last slide. I talked that those two are interchangeable, so I do that to make this a little bit easier, and I can see the square root of 49 is 7, and then I raise 7 to the third power, which I don't even know what that is. Let me get my calculator. And that's 343, okay? Now, let's try this next one. We're going to use the same idea. I know that it's going to be 8 raised to the 5th power, because that's the numerator of our fraction, and that whole thing will have an index of whatever the denominator is, which is 3. Now, I could take 8 to the 5th and then cube root it, and I could do all that in the calculator. Heck, I could put this into my calculator if I wanted to. But just to change it to a problem where we don't have to use a calculator, I'm going to rewrite this the same way we did it in this problem up here. So I'm going to rewrite it as the cube root of 8, and that whole thing is going to be raised to the 5th power. That way I can simplify this first, because I can do that in my head. I can't do 8 to the 5th in my head. You might be able to, but I can't. But the cube root of 8 is just going to be 2, and 2 to the 5th power is just going to be 32. Okay? So we've covered those basic 2 ideas. We've done some practice problems on them, and hopefully you're okay with just the basic ideas of what these fractional exponents mean.